All right, hello lovely humans, welcome to part 2 where we dive deeper into the mathematics of the investment problem that I gave you. Yay! So to recap, you are in 1926 with your BFF time traveling friend Annie, woo! And you happen to find $1, can't take it back with you, so you are going to invest it somehow. And you want to figure out what is the best option given the fact that the stock market is going to crash, but you do have the average annual rates of increase of your dollar given 4 options. So your first option is to put it in a bank, which will give you about 3% increase every year. Your second option is to buy a government bond, which will give you about 5% average annual rate of return. S&P 500 will give you about 10% average annual rate of return. And if you buy a specific stock for a company that will still exist in 2020, you can expect an average annual rate of return of about 12%. So, how do you actually calculate the total value of your portfolio or your bank account or whatever it might be in 2020, given these values and the fact that you're starting with $1? Let's look at the bank account to get a sense of how we do this. Okay, so in 1926, you start with $1. So the next year, you are given an additional 3% to add to your bank account. The bank is like, okay, cool, we will deposit 3% of $1. Well, what is that? Well, we just multiply $1 times 3%, or 0.03, which gives us 3 cents. And then we add that to our $1 to get a bank account ending in the year 1927 of $1.03. Woohoo! All right, so what happens the next year? Well, so now in 1928, we start with a bank account of $1.03. I guess I don't need that parenthesis there. $1.03. And then the bank account adds another 3% to this value. So we have to figure out what is 3% of $1.03. So again, we multiply by 3% or 0.03. And this gives us about 0.0308, which we then add to our bank account to give us 103 plus 0.031 equals $1 and about 6 cents. So now this is year 1, this is year 2. What about year 3? Let's do another year. So in 1929, you start with $1.06. The bank adds another 3%, which would be about 0.0318, and then we add that to our bank account to get, let's say, 1.06 plus 0.032 cents is going to give us about $1.09. All right, coming on up, yeah. So in 3 years, you started with $1 and you ended up earning almost a dime. Woohoo! Okay, so now you just do this all the way to the year 2020 and you figured out what the ending bank account balance is. Just kidding. We don't want to do that. That would take a really long time. And so let's use the work that we've already done to find a pattern in the math that we can then use to figure out an equation. Yay! Okay, so year 1, we end up with $1.03. Year 2, we end up with, we'll draw a little box around this, we end up with $1.06. And in year 3, we end up with $1.09. Okay, so since I've done this a lot, I've done a lot of mathematics, I know what types of patterns to look for. And so immediately what I would notice is, okay, so this is $1.03 to the first power. This is $1.03 squared. And maybe you can see what's coming. This is $1.03 cubed. And if we did another year, you would find that the ending bank account balance would be $1.03 to the fourth power. So this is year 4. So the ending bank account balance for year 1 equals $1.03 to the first power. Year 2 is $1.03 to the second power. Year 3 is 103 to the third. Year 4 is 103 to the fourth. Hey, okay, we're getting somewhere. So it turns out that the total value, whoopsie, I didn't quite erase the year. Whoops. Okay, try that again. The total value, or total val, because I want to be lazy, equals your starting value, which is $1, plus the starting value times the average annual rate of increase, 0.03, to the nth power, where n equals the number of years over which you are accruing interest, or over which you are accruing a rate of return. So this equation is the key. We definitely don't want to do this by hand. So what you need to do is figure out what n is. So you're starting in 1926, you're ending in 2020. So how many years are you earning interest? And then you just plug in n into this equation and make sure that for each of these options, you change this average annual rate of increase, because this will change depending on what particular option you choose. So use this equation to calculate the ending value of the bank account or portfolio that you have, and then use that value to decide how you want to invest your $1 in 1926 so that you can be as happy as you can in 2020 when you come back home via your time-traveling friend Annie. Cool. Okay, so have at it, do some calculations, and let me know what you decide and why. Please let me know if you have any questions, and check out part 3 to check your answers. Yay! Okay, bye!